Good morning, ma'am. Myself B Balaji. I am from Triple E department. Now I wanna going to explain about particle in one-dimensional infinite potential well. Schrod- Schrodinger's equation for a quantum particle. Solutions of Schrodinger's equation in one-dimensional potential well. Energy eigenvalues and eigenfunction are wave functions. Probability density distribution and quantum effect. This is a brief overview of the matter wave. Einstein quantum hypothesis: light is not only a wave but also a particle, and the de Broglie's hypothesis: matter must also exhibit both particle and wave aspects. And the single wave associated to particle, and particle is represented by a group of waves in a wave function. In this, energy and momentum of particle are related to the matter wave parameters in average frequency and wavelength. Observables can be deduced from the psi for a quantum particle. Wave function contains all the information of quantum particles. By using Schrodinger's equation to get the wave function of a particle having motion in a defined potential region, not for all the potentials. And this is the solution of equation for quantum particle. And we are considered as m is mass of the quantum particle, and particle is confined in the potential well in 1D. Defined wave function for a particle is xi x, and time independence coordinate equation is, and this is the equation. Minus h cut square by 2m into dou xi into x by dou x square plus v into x xi x equals to e xi x. For reasons x is greater than or equal to L and x is less than or equal to 0, v into x equals to infinite. Probability of finding particle is 0. Therefore, xi x is equals to 0. For region between boundaries, 0 is less than x and x is less than L. And coming to v into x equals to 0. Particle is free in the potential well. It changes direction at boundaries. We will have multiple solutions for xi x, so we introduce label n. Now minus h cut square by 2m into dou square xi n into x by dou x square equals to en xi n x, and dou square xi n x by dou x square plus kn square into xi n x equals to 1, where kn square equals to 2men by h cut square. Generally, solutions of second order equation equation 1 are xi n x equals to a sin into kn x plus b cos kn x. Use wave function continuity conditions are at boundaries. At x equals to 0, xi n equals to 0. At x equals to L, xi n equals to 0. Then we get b equals to 0. Now solution: xi n x equals to a xi n pi x by L. Note: n equals to 0 is not a solution for n equals to 0, xi n x equals to 0. Use a normalized condition to determine a. At limit 0 to L xi n square dx equals to limit 0 to L a square sin square n pi x by L into dx equals to 1. Final solution Zion x equals to 2 root 2 by L Zion pi x by L. And the energy of quantum particle, use the relations kn square equals to 2 me n by h cut. And energy spacing between energy levels equals to delta E equals to En plus 1 minus En. And delta E equals to 2n plus 1 into E1, and that equals to 2n plus 1 into h cut square pi square by 2ml square. And this is a diagram that energy levels are discrete in nature. Energy of quantum particle is quantized inside the potential well. Minimum energy of a particle E1 equals to h squared pi square by 2ml square is not equals to 0. Energy spacing decreases with increasing the length of potential well. And the Eisen function of quantum particle and probability density distribution. These both are the diagrams for this. For each value of quantum number n, there is a specific wave function. Wave function crosses 0 n1 times in the region n1 nodes. Probability distribution is not uniform. Wavelength of matter wave depends on L and n. Lambda equals to 2L by n. Classical particle. Particle can be stationary in the potential well. E minimum equals to 0, and energy of particle could be continuous. E equals to half mv square. Probability of finding particle is constant at every position at x values. Like quantum particle. Particle cannot be stationary in potential well. E minimum equals to h cut square pi square by 2ml square is not equals to 0. Outcomes of class quantum particle can be represented by a wave function of wave packet is in a finite region. Energy of quantum particles is quantized, and the quantum particles will always be in motion between potential well boundaries. Probability of finding particle will follow CL laws of motion. And this is the brief introduction and explanation about the particle in one-dimensional infinite potential well. Thank you very much, ma'am.